All right, in this video, we're going to talk about suggested homework problems from 2.5. We're going to be talking about implicit differentiation, which is just an extension of the chain rule that we talked about last time. Instead of defining the inner function of the composition of functions as u, it's just hidden inside of the letter y. Y is a function of x. And so we're going to use either y prime or dy dx as our multiplier for the chain rule. Let me show you an example here with number 5. We'll do lots of problems. The book is usually using dy dx as the variable, so that's what I'll do. I'll be using 2x plus 2y times, and here's the chain rule, dy dx. The derivative of the constant 9 is 0. Subtract 2x from both sides. Get 2y dy dx is equal to a negative 2x. Divide both sides by 2y. dy dx is equal to a negative x over y. Let's look now at number 7. X to the 5th plus y to the 5th is equal to 16. So 5x to the 4th plus 5y to the 4th times dy dx is equal to 0. 5y to the 4th dy dx is equal to a negative 5x to the 4th. Divide by 5y to the 4th. Divide by 5y to the 4th. 5's will cancel. Dy dx is a negative x to the 4th over y to the 4th. Let's look now at number 9. X cubed minus xy plus y cubed is equal to 7. 3x squared minus y minus x dy dx using the product rule there, plus 3y squared dy dx using the power rule there is equal to 0. I'm going to keep my dy dx terms on the left and group them together. 3y squared minus x dy dx. This term and this term are alike. These terms that don't have dy dx are going to be subtracted over to the other side. So I'm changing my sign to the opposite when I carry it across the equal sign. This becomes adding y to both sides as a positive y. Subtracting 3x squared from both sides gives me a negative 3x squared. I'm going to divide by this coefficient of 3y squared minus x. 3y squared minus x is dy dx is y minus 3x squared over 3y squared minus x. Apologize, this was squared. So this is 2y, and that makes this 2y, 2y, 2y. There we go. Okay. Start that one again just to be more clear. This was a y squared here, not a y cubed, so this is 3x squared minus y minus x dy dx plus 2y dy dx is equal to 0. And then we're going to keep our dy dx terms on the left. Going to take our other terms over to the other side. Then we're going to divide by our coefficient. And there's our answer for number 9. Let's look now at number 11. Number 11 says x cubed y cubed minus y equals x. So we have 3x squared y cubed plus 3x cubed y squared times dy dx minus dy dx is equal to 1. Keep my dy dx terms on the left, 3x cubed y squared minus 1 dy dx. Take my other terms to the other side, 1 minus 3x squared y cubed. And then we're going to divide both sides by 3x cubed y squared minus 1, 3x cubed y squared minus 1, dy dx is equal to 1 minus 3x squared y cubed over 3x cubed y squared minus 1. Let's look now at number 13. X cubed minus 3x squared y plus 2xy squared equals to 12. 3x squared minus 6xy minus 3x squared dy dx plus 2y squared plus 4xy dy dx equals 0. So we're going to keep our dy dx terms on the left side, 4xy minus 3x squared dy dx, that's this term and this term. Take everything else to the other side. So 6xy becomes positive, 3x squared becomes negative, 2y squared becomes negative. Then we're going to divide both sides by 4xy minus 3x squared, 4xy minus 3x squared, dy dx equals 6xy minus 3x squared minus 2y squared over 4xy minus 3x squared. On to number 15. Starts with sine of x plus 2 cosine of 2y is equal to 1. Derivative of sine is cosine, plus hold that constant multiplier of 2. Derivative of cosine is negative sine. Take the derivative of the inner function, and the derivative of that constant is 0. So we have cosine of x minus 2 times 2 is 4, sine 2y dy dx. carry everything without the dy dx to the other side. So -4 sine 2y dy dx equals a negative cosine x. Divide everything by a -4 sine 2y. We get dy dx is negative and negative make a positive. Cosine of x divided by 4 sine of 2y. Let's look now at number 21. Starts off with x squared plus y squared equals 64. We're told in part A to find two explicit functions by solving for y in terms of x. So y squared equals 64 minus x squared, meaning y equals plus or minus the square root of 64 minus x squared. That means that I'll call this y1 equals the square root of 64 minus x squared, and y2 equals negative root 64 minus x squared. We'll come back to those in a little bit. Now we want to sketch a graph of the function using these two functions. So you could, in your calculator, use y1 and y2, just like I have, and you'll get the top half of a circle of radius 8, and you'll get the bottom half of the circle of radius 8. I'm not great at drawing circles by hand without a compass, so you should have -8, 0 for this point, 0, 8 for this point, 8, 0 for this point, and 0, -8 down here. But this should be the equation of the circle r equals 8. So now that we have that, we want to differentiate these explicit functions for part C. So I'm just going to call this y1 prime, and I'm going to think about this as 64 minus x squared to the 1/2 power. I'm going to think of this one as a negative 64 minus x squared to the 1/2 power when I differentiate it. So I'm going to use the general power rule here, 1/2 times 64 minus x squared to the negative 1/2 power times the derivative of the inside will be a negative 2x. 2 and 2 will cancel, leaving me with a negative x over the square root of 64 minus x squared. y2 prime is going to be a negative 1/2 64 minus x squared to the negative 1/2 times a negative 2x, and 2 and 2 cancel, leaving me a negative as a positive x in the numerator, root 64 minus x squared in the denominator. So there's my y1 and my y2 and my y1 prime and my y2 prime. Let's go ahead now and implicitly differentiate, starting with x squared plus y squared is equal to 64, 2x plus 2y times y prime is equal to 0. So 2y times y prime equals negative 2x. Divide by 2y, divide by 2y, and y prime is equal to a negative x over y. Let's go ahead and break this up now into y1 prime is negative x over y1 is a negative x over, and then y1 is right there. Remember, y1 is root 64 minus x squared. Y2 is a negative root 64 minus x squared. I have those written up here. Maybe you can see them, maybe you can't. So root 64 minus x squared, that's the same thing that I have for y1 prime here. Y2 prime is going to be negative x over y2 is going to be a negative x over a negative root 64 minus x squared. Negative negative makes a positive, so y2 prime is equal to x over root 64 minus x squared. And I get the same answers for y1 prime and y2 prime that I got with explicit differentiation when I use implicit differentiation and substitute those y1 and y2 functions back in. All right, that was 21. Let's go on now to number 25. We have x, y is equal to 6, and we're given the point -6, -1. We want to differentiate implicitly and then find the slope of the graph at the given point. So y plus x times y prime is equal to 0. X times y prime is equal to a negative y. Y prime is a negative y over x. So y prime will be a negative 1 over a negative 6, will be a positive 1 over a negative 6, or a negative 1/6 when the point is at -6, -1. Let's look now at 29. '29 says x plus y to the third is equal to x cubed plus y cubed. And we're at the point -1, 1. We're going to differentiate implicitly. 3 times x plus y quantity squared times 1 plus y prime is equal to 3x squared plus 3y squared times y prime. First thing I see is that there's a common factor of 3 in every term that I'm going to divide out to make x plus y quantity squared times 1 plus y prime equal to x squared plus y squared times y prime. If these y primes get mixed up with your y's, use dy dx instead. That'll be fine. So we have x plus y quantity squared plus x plus y quantity squared times y prime equals x squared plus y squared times y prime. So we'll bring our y prime terms to the left. X plus y quantity squared minus y squared times y prime is equal to x squared minus x plus y quantity squared. So this is x squared plus 2xy plus y squared minus y squared times y prime is equal to x squared minus x squared plus 2xy plus y squared. Factoring out my common factor of x, I have x times x plus 2y times y prime is equal to x minus x squared minus 2xy minus y squared. X squared minus x squared is 0. X times x plus 2y times y prime is equal to a negative 2xy minus y squared. I see a common factor of negative y there. Two x plus y. And so y prime is equal to a negative y times 2x plus y over x times x plus 2y. Because I factored out everything, I can see that there are no common factors and that everything is simplified. If I had left things unfactored, I wouldn't be certain that I had written my fraction in lowest terms. So let's look now at number 31. (31) says the tangent of x plus y is equal to x. And we're given the point 0, 0. Actually, let me go back because I forgot to find the slope here in this last one. So y prime at the point negative 1, 1 that I'm given is a negative 1 times 2 times a negative 1 plus 1 over a negative 1 times a negative 1 plus 2 times 1. So y prime at negative 1, 1 is a negative, 1 goes away, negative 2 plus 1 over negative 1 times negative 1 plus 2. These negatives will cancel each other out. Negative 2 plus 1 is a negative 1. 2 minus 1 is 1. And we should have a slope of negative 1. All right, let's move on now to number 31. 31 says tangent of x plus y is equal to x at the point 0, 0. So the derivative of tangent is secant squared times the derivative of the inside is 1 plus y prime. Derivative of the right-hand side is 1. So we can go ahead and solve for y prime here by dividing both sides by secant squared of x plus y. 1 over secant squared of x plus y will be cosine squared of x plus y. So y prime will be equal to cosine squared of x plus y minus 1. Remember that sine squared theta plus cosine squared theta equals 1. So sine squared theta will be 1 minus cosine squared theta, which is the exact opposite of what I have here. I have cosine squared minus 1. So a negative sine squared theta will be cosine squared theta minus 1. That means that y prime is a negative sine squared of x plus y. Now we can evaluate it at 0, 0. So negative sine squared of 0 plus 0 would be a negative sine squared of 0. So say negative sine of 0 squared. Negative 0 squared is 0. Right? 0 squared is 0. Negative 1 times 0 is 0. The answer is 0. All right. Let's look now at number 35. Says that x squared plus y squared is equal to 4x squared y. And we're given the point 1, 1. So 2 times x squared plus y squared times 2x plus 2y times y prime equals 8xy plus 4x squared y prime. So we have 2 goes into everything, 2, 4, 2. This is x squared plus y squared times 2x plus 2y times y prime equals 4xy plus 2x squared y prime. There's still a common factor of 2 in everything. 2, 2, 1, x squared plus y squared times x plus y times y prime equals 2xy plus x squared y prime. So now we're going to distribute to get rid of these parentheses. So we have x cubed plus x squared y times y prime plus xy squared plus y cubed y prime equals 2xy plus x squared y prime. So we get our y prime terms stay on the left. X squared y plus y cubed minus x squared y prime. And everything else comes to the right, 2xy minus x cubed minus xy squared. And we have y prime equals 2xy minus x cubed minus xy squared over x squared y plus y cubed minus x squared. Now we need to evaluate that at the point 1, 1. So that will be 2 times 1 is 2, minus 1 times 1 squared will be 1 over 1 times 1 is 1, plus 1 cubed is 1, minus 1 squared is 1. 2 minus 1 is 1, minus 1 is 0, over 1 plus 1 is 2, minus 1 is 1, and this is 0, and the slope of the tangent line at 1, 1 is 0. There. Not sure if you can see that, but that has a horizontal tangent line right there. All right. Let's look now at number 39. 39 is a little different because not only are we told to find the slope, but we're told to find the tangent line at the given point. So 39 says x squared y squared minus 9x squared minus 4y squared equals 0. So we're told that the point of interest here is -4 to root 3. So we're going to implicitly differentiate 2xy squared plus 2x squared y times y prime minus 18x minus 8y times y prime equals 0. Keeping my y prime terms on the left, 2x squared y minus 8y times y prime is equal to, and take the other terms over to the other side by subtraction. So y prime is equal to 18x minus 2xy squared over 2x squared y minus 8y. I see everything has a common factor of 2, so that becomes 9x minus xy squared over x squared y minus 4y. Now we're going to evaluate that when we're at the point -4 to root 3. So 9 times -4 minus a -4 is 2 root 3 squared over -4 squared times 2 root 3 minus 4 times 2 root 3. Y prime at -4 to root 3 is a -36 minus a negative is a positive. This is 4, and this is 4. 2 squared is 4. Root 3 squared is 3 over, this is 16 times 2 root 3 minus 8 times root 3. So y prime at -4, 2 root 3 is 36. It's negative. 16 times 3 is 48 over, this is 32 root 3 minus 8 root 3 will give me a 12 over 24 root 3. 12 goes into 24 2 times. So y prime at -4 to root 3 is equal to 1 over 2 root 3, which I will rationalize here as root 3 over 6 for my slope. Now I have my point here, I have my slope, so y minus 2 root 3 is equal to root 3 over 6 times x minus a negative 4 is x plus 4. I'm going to finish this up like the book did. It did not leave it in point slope form. So root 3 over 6 times x plus 4 root 3 over 6. We'll simplify, that's a 2 and that's a 3. Y is equal to root 3 over 6x plus 2 root 3 over 3 plus 2 root 3 over 1 times 3 over 3 to make a common denominator for my constant part. Y equals root 3 over 6x plus 2 root 3 plus 6 root 3 over 3. Y is root 3 over 6x plus 8 root 3 over 3. Let's look now at number 45. Number 45 is an ellipse problem, and we're given a specific ellipse, x squared over 2 plus y squared over 8 is equal to 1. And we're going to be at the point 1, 2. And I'm just going to note for later that in this problem, this is in the form of x squared over a squared plus y squared over b squared is equal to 1, where a is equal to the square root of 2 and b is equal to 2 times the square root of 2. Not to worry too much about that right now, but that is our ellipse that we're talking about here for part A. So we're going to use implicit differentiation here, 2 times x over 2 plus 2 times y over 8 times y prime is equal to 0. So we have x plus y over 4 times y prime is equal to 0. Y over 4 times y prime is equal to a negative x, and y prime is a negative 4x over y. At the point 1, 2, y prime at 1, 2 is equal to negative 4 times 1 over 2 is negative 4 over 2 is a negative 2. That would give me a tangent line of y minus 2 is equal to this m of negative 2 times x minus 1. Y minus 2 is equal to negative 2x plus 2. Add 2 to both sides. My tangent line is y is equal to negative 2x plus 4. Hang on to that. Come back to that after part B. Remember, I'm just going to note here that in part A was equal to the square root of 2, B was equal to 2 root 2, and we were in the form of x squared over a squared plus y squared over b squared is equal to 1. Okay, so for part B, we're told to take our generic equation of x squared over a squared plus y squared over b squared that equals to 1, and implicitly differentiate it to find y prime. So 2x over a squared plus 2y over b squared times y prime is equal to 1. So 2y over b squared times y prime equals this equals to 0, differentiating. It's equal to negative 2x over a squared. And then we are going to have y prime is negative 2x over a squared times the reciprocal of this will be b squared over 2y. The 2's will cancel. Y prime is equal to a negative b squared x over a squared y. All right. So maybe you can see already, but in our first part, that would make y prime equal to b squared was 8x over a was 2y. So my y prime for our first problem would be negative 4x over y. And we'll see that we had a x of 1 and a y of 2. Will give me negative 4 over 2 is a negative 2. I'm just showing you that this is working, and my slope here was negative 2 for my tangent line. Look at that. Okay, so we're on track. Now, this is going to get a little trickier because we're given generic point x0, y0 here. So we need to write this tangent line as y minus y0 equals m, which is this thing here. But this is, we're plugging in our x0 and y0 here, times x minus x0. Now I'm not going to do the traditional multiply all this stuff across and try and solve for y, because I'm trying to get this to look like a different form here. So what I do want to do is I want to get rid of this y0 that's in the denominator and multiply it to the left. So this is going to be y0 times y minus y0 squared is going to be equal to negative b squared x0 over a squared times x minus x naught. I'm trying to get something that is going to be helpful for seeing the original equation here of x squared over a squared plus y squared over b squared is equal to 1. So I'm trying to get x naught squared over a squared plus y naught squared over b squared into my formula so that I can replace it with 1. Just my goal of what I'm trying to do. So I want y naught squared to be divided by this b squared. So y naught y over b squared minus y naught squared over b squared is equal to a negative x naught over a squared times x minus x naught. Now I am going to multiply that stuff on the right now. That's closer to what I want. So y naught y over b squared minus y naught squared over b squared is equal to a negative x naught x over a squared plus x naught squared over a squared. So bringing this term to the left and this term to the right, I have x naught x over a squared plus y naught y over b squared is equal to x naught squared over a squared plus y naught squared over b squared. And I already told you that that right-hand side was 1. So x naught x over a squared plus y naught y over b squared is equal to 1. I showed you that by just making the substitution for the generic point into my original formula. It will still equal 1. And so now I have the generic equation of the tangent line. And just for fun, let's go ahead and let's look at what we had for part A and prove that it works here. So we have the point 1, 2. That's my x naught, y naught here. And I told you before that my a was equal, my a squared was equal to 2, and my b squared was equal to 8. So let's make those substitutions now. 1 times x over 2 plus 2 times y over 8 is equal to 1. That gives me 1/2 x plus 1/4 y is equal to 1. 1/4 y is equal to negative 1/2 x plus 1. Y is equal to negative 2x plus 4. And there's my tangent line that I had for part A. I have 2 more problems. Let's go ahead now and look at number 53. Asks me to find the second derivative, 7xy plus sine x is equal to 2. So that's 7y plus 7xy prime plus cosine of x is equal to 0. We want to solve for y prime. So 7xy prime is equal to negative 7y minus cosine x. For reasons that we will see later, I'm just going to put a star next to this. I'm solving for y prime, but I'm going to end up using the form that I have the star next to later in the problem. So now I want to find the second derivative using the quotient rule here. So derivative at the top is a negative 7y prime plus sine x times my denominator of 7x minus my derivative of my denominator is 7 times my numerator of negative 7y minus cosine of x all over my bottom squared. I see a common factor of 7 in everything. So I'll divide that out. Y double prime is equal to a negative 7x y prime plus x sine x plus 7y plus cosine x all over 7x squared. Now, do you see the 7xy prime and the 7xy prime here? There's just a -1 multiplier, so I need to change the signs on the right-hand side there. Y double prime is equal to, this is going to be 7y plus cosine of x for this part, plus x sine of x, plus 7y plus cosine of x over 7x squared. And y double prime is 14y plus 2 cosine of x plus x sine of x over 7x squared. Final problem for this video will be number 61. We're told to find the vertical and horizontal tangent lines where they occur. So the points at which the graph of the equation has vertical and horizontal tangent lines. So 61 is 25x squared plus 16y squared plus 200x minus 160y plus 400 equals to 0. Really, that 400 isn't going to do me any good, so I'm going to take it to the other side for right now when I'm going to differentiate. There's a reason it's over here right now, but when I'm about to differentiate, it's just a constant that's going to go away. So it might as well be over there with the 0. So let's differentiate implicitly with respect to x. So 50x plus 32y times y prime plus 200 minus 160 y prime is equal to 0. Now let's solve for y prime. So this is 32y minus 160 y prime is equal to negative 50x minus 200. I'm going to do a little bit of factoring here in a second. Y prime is equal to, let's see, negative 50 times x plus 4 over, and then this is going to be 32 times y minus 5. So my horizontal tangent lines will come from when the numerator is 0. So horizontal tangent is going to come from when negative 50 times x plus 4 equals 0. My vertical tangent is going to come from when the denominator is 0 because the slope of a vertical line is undefined. So that'll be when 32 times y minus 5 equals 0. I think it's pretty clear that you can see that this happens when x equals negative 4, and this happens when y equals 5. So now we need to go back to our original equation and make substitutions and solve for the remaining variables. So when x is negative 4, we have 25 times negative 4 squared is 16 plus 16y squared. Negative 4 times 200 is negative 800 minus 160y, and that equals to negative 400. So let's go ahead and look here at 4 times 25 is 100, and that has another 4, so this is 400 plus 16y squared minus 800 minus 160y equals negative 400. So if I subtract 400, I get negative 800, and then add 800 to both sides. All of these constants will make a 0 on the right-hand side. We have 16y squared minus 160y, but I can factor a 16y out and get y minus 10 is equal to 0. That gives me 16y equals 0, or y minus 10 equals 0. So y equals 0 or y equals 10. Remember, x was negative 4, so that gives me the point negative 4, 0, and the point negative 4, 10, where I have horizontal tangent lines. If y is 5, then we get to come up here and say 25x squared plus 16 times 25 plus 200x minus 800 is equal to a negative 400. So this is 25x squared plus 400 plus 200x minus, add that 800 to the other side is 400. So this 400 and this 400 zero each other out, plus 200x equals 0. Going to factor out 25x, get x plus 8 is equal to 0. So 25x equals 0, or x plus 8 equals 0. X equals 0, or x equals to negative 8. Remember, I need ordered pairs that are x, y, so I have 0 and then 5, and 0, negative 8, 5 here, and these are my points of vertical tangency. All right, that's it for this assignment and this section, and we'll come back next time to talk about 2.6, which will wrap up our discussion of chapter 2. So see you for the next video.